Oh, hi everybody. Wasn't going to do any astronomy tonight, but because I didn't think it was going to be clear, but it was, which meant we could get out under the stars. We're looking at M56 now in Lyra. It's a globular cluster, 33,000 light years from Earth. Not as impressive as something like M5 or M13, but we've been stacking 25 frames now. It's 3 minutes and 20 seconds of data. Tonight, again, we're not using any dark or light frames. We're just using hot pixel removal set to level 6, which seems to be good enough. And we're using dithering, and we're using gradient removal. Are we quite high up here? I think let's just a little check. We're at 67 degrees. And so we're getting some, in the corners, I can see it already, we're getting these kind of elongated stars because we're quite high up, and we are also, we are also 148 degrees. So it's not ideal. So we get field rotation on my telescope because I'm using a CPC-800, hence this is EAA, electronically assisted astronomy, with an 8-inch Schmidt-Cassegrain, and a CPC-800 is an 8-inch Schmidt-Cassegrain, a C8 from Celestron, and it has two arms, and the telescope's in the middle, and it goes up and down, and then the whole mount can go, north south type thing, east west. So that's the way it works. And in the east and the west, exactly, and as long as you don't go too high in altitude, you don't get very much field rotation. But where the stars are going across the sky, they arc across. Your telescope, my telescope doesn't arc, it just keeps a nice straight line. And because of that, the whole field seems to spin. It's called field rotation. To be honest, it isn't a problem. Even though I can see now up here that we've got lots of field rotation, and we've also got some black bars because of the dithering that's going on as well as the field rotation. We're only interested in this portion of the image here. That's what we're looking at. And because of that, who cares? Well, some people might, but I don't. And we're looking at this ball of stars, M56. Which, let's zoom into, just, oops, I don't think I selected it. So here is the little ball of stars. Nowhere near as impressive as some of the other globular clusters we looked at, but still, we can make out these streamers of stars. I'm not sure how old M56 is. As we know, globular clusters are usually quite old, forming billions of years ago. Some of them ripped off other galaxies that have come too close to our galaxy. Some of them could even be the cores of those galaxies, the leftover remain of the core of the galaxy, the dwarf galaxy that got ripped up. We looked the other night, I think it was M53, wasn't it? And we think that could be a binary globular with, I can't remember what it was it NGC 5053? I think it was. Anyway, better check that. Don't take that for granted. But and that could have come off the Sagittarius dwarf galaxy, which is currently being ripped apart over millions of years by our rather larger Milky Way. M56 then, 5 minutes 52, 44 seconds. I think we've seen enough of that. I think what we'll do now, we will go back to, we'll go to something different. We're going to a Planetary Nebula.
M57 selected.
The computer now speaks. There we go. M57 is selected, and M57 is a very famous object in the sky. It's a Planetary Nebula. I think we shall slew to M. Oh, we're not connected to the telescope. Let's connect. Sorry. AstroPlanner was not connected. That was my fault. It is now. The distance between this. Oh, I didn't realise it said there. The distance is 5.7 degrees. Okay. Well, let's slew to M57. And while we're at it, let's change the banner and let's go into observe mode. Oh, sorry, fly mode, sorry. And if I go into fly mode, no, then it saves it nicely. We're at 8 seconds, but we're going to come to 1 second. And let's stretch the image. So, oh, hello, M57 applies Planetarium Nebula. Now, I must admit, I always liked M57 visually through this same telescope, a little smoke ring in space. But I think you might agree, I'm only going to do 4 seconds. This is crazy talk, by the way. I'm going to do 4-second exposure on M57. And the reason I'm going to do that is that M57 is quite bright. And even though I know... Sorry, are we not... It's a rather bright object. The blue is stubbornly wanting... No. There we go. So let's zoom in. Let's zoom into 100% and see what we can see. Oh, we're way above 100%. So we've got a central star. There's another little star to the side. In fact, we are going to zoom in a bit more. So we're way over 100%. This is the Ring Nebula. We have this kind of red all the way around the edge, and it feathers off on this side. This is the central star that kind of puffed off its outer layers. And then, obviously, with the very hot plasma and you know, cosmic rays that comes off the sun, the excited particles that come off the sun, the solar particles, they excite the gas and cause it to glow. And we've got kind of a red ring, red green. We've got another little star there. There's another little star there, if we leave it. Got no enhancement on, that's good. Zoom in on this. Let's twist it. My telescope flips east-west, so I need to flip my planetarium to see the same thing. So we've got the central star here, we've got another star here. There are 2 stars, one there and one there on the edge. And we are at 346% zoom, by the way. But I just wanted to show you what we see around the edge. And all this you see here is noise. So we've stacked 24 frames so far. We've ignored 8 because we are currently dithering, which is moving slowly, within up to 20 pixels in this random walk, so that we can smear noise over loads of pixels and then average itself out over time. If I go back to 100%, there we go. Increase the colour a bit, but I'm also going to bring the red down because it's not quite right. If I zoom. Now, I'm only working at 4 seconds, which I think maybe we should have worked it a bit more, but I wanted to preserve this kind of structure in it a bit more. Now, there's lots of structure in this one, as you can see. But 31 frames, 2 minutes, 4 seconds worth of data. And if I zoom out to the full telescope's field of view, we can see a couple of things happening. We can see field rotation happening, and we can see the dithering effect happening as well. And we can also see, actually, if I zoom in a bit, there's also a galaxy right here. IC1296. Should we take a look at what's that? That's doesn't tell. Gives me a redshift, which is positive, so it's moving away. It's an active galaxy. It's 15.4. Is it a barred spiral? No, it's a barred spiral, yeah. It's a little barred spiral galaxy right there. And in order to confirm that, what I could do is let's do deep sky annotations. And for that, we have to do a plate solve. Well, there we go. So I can just see, yeah, there's a galaxy there, there's another galaxy over there, and of course the Ring Nebula, which is there. Any objects nearby? There's some stars. Oh, there's a comet, which, now, yeah, Comet C22 ZTF. I should explain. So in the last session, what we were doing is that we were looking at asteroids and comets, and I was looking at M57 a while ago, and I noticed in Stellarium that there was this comet C22, is it E3 Z2F? Let's have a look. Let me spin it so I can kind of get a good, there it is there. There was this comet. There it is, C22 E3 Z2F. So last night what I was doing was I was taking a picture of the asteroids or the comets, and I was then putting them into a program called ASTAP, and I was asking ASTAP to solve. In fact, I've got ASTAP up here, have I? Yeah. And I did it just now as well. So this is Comet 22E3, which is off to the right of M57 we're looking at. And I did a plate solve, and then I asked it to annotate any comets or asteroids within the same field of view. And it said, yay, that's great. But what I did was I went to the JPL, is it Minor Planets database? And I went for a lookup, and I said I wanted C/2022 E3. I could have put ZTF in, but I'm not going to. And it finds the object for me. But one thing it does do is that it allows me to get this, the actual exact position as of right now. So there's the target. Geocentric means the center of the Earth. Now I could put in my latitude and longitude, but what I noticed with the asteroids, because I was trying that earlier today with the data I got yesterday on Daphne and was it what was the name of it? Melpomene, and another one, Cork, was it, or something? I noticed that geocentric to my location only altered it by a fraction of an arc second. If it was closer, I think it would alter it by quite a way, but we'll keep with geocentric, which is the center of the Earth. And I'm going to specify the time. What's the time now? 0046. So that's, I'm going to specify the time as 23:46 to midnight, because this is in UTC, which will only, I'll use that specified time, and the JPL system will then generate to me this table of the exact positions of the comet. Now it just so happens, he says, that I have here, because we were looking at Comet 3197 Weissman, not Comet, sorry, Asteroid 3197 Weissman, I've actually got the position data here. So what I'm going to do is I'm going to move that out, if you don't mind, and I'm going to highlight 2346, 2347 now. I'm going to do 2348, which is 18 hours, 48 minutes, 36, oh, it's moved a bit, 36.41 seconds, and it's 32:57 minutes and 11.7 seconds. Now this format which I'm using is the format that SharpCap recognizes. So if I get that format, and what I'm going to do first of all is I've never done this before, by the way, I'm going to center my old position, and I'm going to move it. Yeah, I am. I'm going back into observe mode as well. Oh, sorry, into find mode, sorry. So this is going to, so this is SharpCap moving the image to here. Now, I'm going to do a nearby, because it thinks the comet is right there. But what I'm going to do is I'm going to clear 0 objects, and I'm going to paste my custom object in. And so this is where I think the comet roughly is. So if I zoom in, oh wow, it's moving up towards that galaxy. Oh, easy. We're at 237%. I'm going to do another plate solve second. Ah, there you go. Sometimes it does it. So there, right there, is the galaxy, is our actual comet. It actually went right over the top of it and then jumped. It's right. That is our. It doesn't. It's not very responsive, is it? Let's do another one, and that is our comet right there. There you go. So it's right over the top. Then it moves slightly because my telescope's rubbish. But that is our comet. So that is C 2022 E3 Z2F. It is currently 438 million kilometers from Earth and has a magnitude of 13.93. And we got that without going into ASTAP by using JPL's great tool, the Horizon system, which also has an API. So that gets you thinking that you could auto-generate that this string. You could put it onto the clipboard and click paste, and away you'd go. You could start identifying comets using the deep sky image annotation. When it's not really deep sky, it's a comet. But that's great. And this is a web service, so there's an API associated with this here. In fact, I do believe on my desktop I have got. So this is Weissman. So if I get this up again and bring up another tab, this is a query which brings back the data for is it 30 minutes or on 2023 to 2053? Yep. So we've got 30 minutes of data from the other night on Comet Weissman, which you could then pick off and use. So this is API version 1.1. And I specified what I wanted in the URL that I send it to with all these parameters to get the exact position of any objects. And it also has lots of, it has another query where if you provide it with, say, the center, RA and deck, and then the half span, if you want, of the area, height and width, it will tell you what objects it has in its database are actually within that area, and you can then limit it by magnitude and everything. So it's pretty neat and an interesting way of possibly feeding this, which you can do, which I thought you could do maybe with a script. It's come out of 316%. So that's it there. I mean, should we just highlight it one more time? It's not there. It's actually there. There it is. It's up there. And then my telescope moves a little bit, but it's right there. I can see it right between those purple points. There is, in fact, a comet, which is good. So that was intriguing. That was something I was working on today. So that we could... ooh, sorry, I didn't mean to do that. I was... oh, what am I doing? Why isn't it coming up? Ah. So yes, that was what I was working on today, was how to use that data, because I found that some tools seem to be better than others at pinpointing the orbital calculations, I suppose, of asteroids and comets. So I have to choose my tool carefully, but if I don't need to, I can actually get the information from JPL. So there we go, Comet, no problem. We've looked at M53, we've looked at M27. I think what we'll do now is let's go down to the Dumbbell Galaxy, the Dumbbell Nebula, sorry. I always say galaxy, I don't know why. So the Dumbbell Nebula is another planetary nebula. M27, in fact, which I seem to have managed to lose. Oh. Where's it gone? Maybe I haven't put M27 in. How rude of me. No, I haven't. Look at that. There's M27. Let's change it to there, and let's slew to M27. Let's change the rate to a second so we know when we've arrived. Let's go into fine mode. So M27 is another planetary nebula where the star has blown off its outer layers, but planetary nebulas have a way of blowing things off, and then of course the solar wind coming off of them and gravity and so on, it can twist them into beautiful shapes. M27 is right there, I can see it right now. I'm going to go for because we seem to be at 10 seconds, and we're going to observe mode, which shows us there, and we'll get rid of the display stretch, because we're going to stretch this in a second. I don't like that. Consistent. Let's take it up a bit then and see what we get next. Even higher. I wonder if we're drifting still. I noticed we were drifting upwards. Oh, there you go. And you can see these kind of shock waves coming out. The reason it's called a dumbbell, obviously, it goes in at the edge. It goes in the centre, or it looks to anyway. Looks like we have a sphere, but look at it here. Oh, let's spin it so that we can flip it so it looks the same. Wait, just zoom in a bit here as well. Oh, we're not doing very well. These stars are definitely. I'm going to clear this and start again. We definitely drifted downwards, I think, on that, or upwards, whichever way you want to look at it. Judging by those stars, we're still drifting. Stars seem a bit stretched to me. We are at an altitude of 58 degrees, 145 degrees in azimuth, and those stars don't look right to me. They're definitely moving. Well, I mean, we can see they're definitely moving. Let's clear again. We'll do once more with feeling, I think. It's better. It's not good. It's not the best. Let's come off the zoom. Actually, no, it's not. Let's bring the colour down a bit. Let's push the reds up a little bit. Oh, not that far, maybe. Don't overdo your reds. And the blues are nowhere in sight, so we'll move those up. And we overdid it again, so we'll bring them down. And there we go. And our mid-level. In fact, if we do a auto stretch, does that look better? Yeah, there you go. We could move our little black level up a bit. Move our mids up a bit. Give it a good stretch. Yeah, there you go. And there we have M27, the Dumbbell Nebula. 861 light years from Earth, Planetarium Nebula. That's, I mean, I take it that's the central star. It looks rather central to me, but I have no idea if that's true. Because obviously it depends how you're looking at it. Whether these really are circular, a sphere, or whether it's twisted in some way. I mean, these lobes out here and out here. There's two lobes that way, and then of course there's this here, and it's almost like I can't remember if this is the material from another expansion hitting this and causing it to glow in red, or whether this is hitting the outside of some interstellar space and causing it to glow red. But something to look up. So we're at 2 minutes and 10 seconds. And we're 20 minutes into this stream, so we will spend just maybe a minute. It might be worth just getting some information on the Dumbbell Nebula from our trusty source, Wikipedia, which we found knew most things. So it says it's a distance of 1,360 light years. Okay. Is there a plus or minus on that? I don't know. It's about it's easily visible binoculars. Yeah, shape and size. We know about structure. Central star. The central star is a white dwarf, which gives, just a white dwarf. Not much information on it, really. We're at 3 minutes 20. Our colour's slightly off. Let's see if we put an enhancement on whether that... It doesn't help with the star colours, but it does help... There we go. This is zoomed at 70%. Let's zoom it into 100%, see what we can see. Drag it down a bit. I take it that's the central white dwarf star. I might be wrong. We've got these layers. There's another little shock wave you can see up here as well, almost. And down here you can see this fuzzy bit to it. So that bit's almost, these do more, it's hard to tell, isn't it? I mean, this thing is, well, they think it's, well, I think it's 861 light years away. Most probably because I got it from Stellarium, which also thinks it's 861. They think it's further away. So, but I'm pretty sure that Gaia would have been able to pinpoint this star here and most probably associate that with this nebula, but I suppose it's hard. Let's just go back so we can see the entire field of view. We're obviously sat, if we come out of here, we are sat within the Milky Way, so there's absolutely a huge amount of stars here. I mean, the Milky Way is made up of billions of stars, and this obviously reflects it. And this is a nearby Planetary Nebula, a star that's puffed off its outer layers in its death throes. Galaxy there, but it's 13.54, doesn't look that interesting. Oh, I looked at that the other night. Again, not the most interesting thing in the world. What I thought we'd do is, we're past south, aren't we? Yeah. Is we would go down. There's the Lagoon Nebula. That we might head down towards the Trifid Nebula and take a look at the Trifid Nebula, which the other night was really quite good. So we've already looked at the Eagle Nebula, we looked at the Omega Nebula, and I think it's worth taking a look at the Trifid Nebula, which is M20. I think we're saying that's done. That's 6 minutes, 36 seconds. So we're going to come out of there. We're going to go into fine mode, we're going to change it to a second and stretch it. I need to update the script so they do this automatically, actually. We're going to go down to M20, which is the Trifid Nebula. And hopefully we're slow. So we're only at a height of, we're 22 degrees again, our favourite altitude. I think it's 22 degrees, have a look in the right place. Yeah. Oh no, 15 degrees. Sorry, I was looking at the declination. It's 15 degrees. So it's 15 degrees and it's 192. So it's coming out of a light dome of a nearby town. We appear to have arrived. And what we're going to do is let's do a single 10 seconds exposure, and we should be able to see some nebulosity. Oh, there it is. So it's actually down here, and it should be up here, but there's those bright stars there. So what we will do is, do you know, should we try plate solve? I feel lucky. It's solving, or it's found it. It knows we were 0.04 degrees off. So we were trying to get those two stars that were there, we're trying to get them up here. Did we succeed? I don't think we did. No, we moved from where my cursor is now to there. Okay. We are going to go 1 second quick pick because we know that that is the star that we want to move up. So we're going to move this star up. And we're going to move it along. And those are the double stars there, aren't they? Oh, we've gone too far. We're going to come back out again. I'll move it up a little bit, but not much. I'm going to say that's good enough. Right, so I'm going to set a 10-second exposure, and I'm going to go into observe mode for M20, the Trifid Nebula, which looks quite impressive, has to be said. Oh, we're nearly there. Hopefully the first image. Oh, I'm zoomed in. Let's zoom out. That didn't work so well. Oh, we're quite high. Maybe we should have focused first. Yeah, okay. I heard you. It's 1 second mode. Let's stretch it. Let's do a multi-star FHWIM. Yeah, that'll do. I've got a sequencer thing that does a fine autofocus. Oh. Go on then. Oh, fine autofocus. Why not? So we're just running a sequencer file to see if we can make this a bit sharper, because obviously we're moving in the right direction, because that increases when I say that, and then we realise we're just fighting the atmosphere. I mean, this is quite low. This is what we say, 15 degrees. Oh, we're still getting within focus, so we were definitely out of focus, and that double star's looking a lot better as well. Oh, even better. The problem is you don't know is it the focuser moving or is it the atmosphere moving? Because we seem to have had problems with focus all session. Even before I started the live stream, we were having a few problems with it. So we've definitely got a downward curve, so that's good. So we're definitely getting more and more into focus. Oh yeah. We really are. It's 36 stars now. Did that fail? Nope, still going. 6 of 7. Part of me wants to stop it. Sequence halted due to errors. Let me move to that direct. Move to that direct. Okay, let me try this. Let me move that direct, which was obviously awful. But now isn't quite so bad. Let me move to that directly. I think we have a lot of backlash in our focuser. But anyway, I'm saying I'm calling it on that. We're going to set that at 10 seconds. And we're going to go into observe mode. And we're going to reset that. And we're not zoomed. We're going to reset this. Should we bring Stellarium back into play? That didn't look right. That's better. And we're still above what we should be. Okay, fair enough. Okay, let's clear that. Let's try again. We got in 10 seconds at, where are we on? At 15 degrees. There's our first object. Let's do let's see if we get another one. Yes, so let's do a stretch. And there is a Trifid Nebula. So a few more images to build up before we start. A few more frames. Definitely see the dark clouds, the dark lanes, should I say, the dark nebula. Zoom in a bit, move it up, make it as big as, oh that's not zipped, there you go. So that's what they both look like now. So it's also kind of like a blue hair kind of flying off this over here. So right, the blue needs more apparently. There's the blue. There's the red. Let's boost the colours a little bit. Oh, we've got our enhancement on, haven't we? Which is almost certainly dulling it a little bit. Oops, off. Ah, yes. That was hiding this kind of blue nebulosity around here. So the Trifid Nebula. What's the distance? Oh, it's of course called the Clover Sagittarius. What's the distance of this one? 5,219 light years. Let's find some information about the Trifid. Here it is. It's in 102 region in the northwest of Sagittarius. It's a star-forming region in the Milky Way Scutum Centaurus arm, discovered by Charles Messier on June the 5th, 1764. Anything of interest? Read ourselves. So we've got 17 frames stacked, 2 minutes 50 so far. We can already see this kind of blue nebulosity above it. And we can see obviously the red nebulosity coming off of it with these dark arms. Well, it does not dark arms at all, it's dark clouds. Now on here there's this kind of dark cloud here, but there's also this kind of silhouetted, there's obviously a star behind it silhouetting this bit right here. You can kind of see around the edge, it's lit up almost like there's a star. It's like the pillars of creation and things like that, where there's a star embedded behind it, and it kind of illuminates from behind, backlighting the nebula. And it's backlighting this bit here, which is, if we zoom in a bit more, oh, we don't go above 100 really, do we? You can see this bit here. It's kind of backlit a bit. And that's that bit here. I'll just do that star, so there's that bit there, where this bit comes down, and this bit comes down. There's more intricate detail over here. There we go. Let's come out a little bit more, 33%. Oh, that's no good. 50%. There we go. The Trifid Nebula. Now, I did spend some time on this last night, and it was more impressive. I don't know, seeing conditions are a bit different tonight. It's 4 minutes 30 seconds. It is only 14 degrees high, 195 degrees. Oh, excuse me. 15 degrees off south towards the west. But it is quite an interesting sight, isn't it? Stars forming within this region of space. We're at 5 minutes 10 seconds, 31 frames. Shall we? We'll darken it off first of all, and then we'll bring in the stretch slowly to reveal this huge nebulosity sipping. You see this initial nebulosity, and then this builds all the way around. Sometimes Viner seems to help a bit. In this case, I'd say no. We'll leave it. I think I'll just on that. Let's save it as exactly as seen when we get to 6 minutes. While we're thinking about that, let's think about the Lagoon Nebula. M8. So last night we finished on much higher up. We were over here in these dark nebula here, if you remember, and they were dark nebula. I missed out that one, and actually I didn't. Down here, as you may notice, there is a trio of asteroids I did have a little look, and I could resolve. I think it was that Tachibana, 5141 Tachibana. I could resolve, but the other two I couldn't. They were too faint for me to resolve. Lagoon Nebula is pretty impressive, it has to be said. So we're at 7 minutes 30 with the Trifid right now. Let's have a little zoom on into the Trifid. There you go. I don't want to lose too much of his hair, if that's what his hair is. It looks a bit like hair, as I was saying. This up here, this big blue nebulosity. Or this is not. This is the lagoon. I'm just looking at that for later on. Nice dark lanes. There's noise in the background, but it's quite smooth. There's no repeating patterns or lines, so I'm quite happy with that. A little bit more. Use the shift key and just move it up a little bit more. But there you go, the Trifid Nebula, M20 in Sagittarius. It's one of those objects you don't really want to move away from. Sometimes, yeah, that's right, I'm moving away from you. You sometimes get that with an object, that it's one of those ones you want to build up and just look at the different clouds forming, you know, the different structure parts of it. And it takes a view, I think, which is quite nice. We're at 9 minutes and 10 seconds. We have 55 frames we've built up so far. If we see what the whole frame is, there you go. We have field rotation and dithering causing these lines down here. But you see, that's the whole point. We can just zoom in and leave the edge bits behind, leave the bits that we don't want behind, and we just do that. Now, I have a thought though, you know, it says down here, it says save exactly as seen, but it doesn't save exactly as seen. It saves the entire image. It doesn't save where I've framed the bit of image I want. It's almost like you want to save as framed. Save exactly as seen and save exactly as seen, but also frame, please. You know, if that helps. I'll save a FITS file there. I don't normally save FITS files anymore. I used to religiously, save a FITS file, then I'd save, you know, the PNG files at the end. But why? They're so big. It takes up all my space. There we go. Then we're at 10 minutes and 10 seconds. Let's pause that. Let's go into fine mode. And we'll go back to a second, and we will stretch just to, it's still there. And let's do the current object. Actually, no, let's not. Let's, and then let's slew to the object. 1.4 degrees worth of slewing down to the Lagoon Nebula M8. We are now got a height of 13 degrees. Oh, there it is there. So we've got these clusters. Actually, let's see what we've got here. We've got clusters of stars over here. I have no idea. So what I do is we'll do a 10-second exposure just to see what we've got. Because otherwise we're just guessing on the framing. I'd say that's low. So we go back to the second, and we come up. And we go back to the 10-second. And we will go into observe mode with the M8 Lagoon Nebula, which is another filamentary structure, regular form, distance 4,077 light years, another HT region, another star forming region. Just wanted to see what it did. It's the starfish cluster. Is that that's NGC? I don't think we could go much lower. Ooh, we made it full screen. There you go. We made it full screen. Sorry about that. We're back again. Let's not do that. Reverse it. A great Sagittarius cluster at a distance of 9,786 light years. Wow. Anyway, we're at 5. We're not stacking, are we? Oh yeah, we had 2 duffs. Oh, what's our brightness? No, we're okay. Enhancement is off. Yeah. Let's pull up the blacks. Make it a bit darker. And then stretch it a bit more to really wow. This is the bar here. Got the bar here. Some dark globules of dark matter all the way around here. Red's a bit too much. The blue most probably isn't enough. Oh, it does. Lagoon Nebula. Now that's another impressive nebula with these black lanes going through these black dark clouds. And these just, I mean, we're well, this is full. This is the best we can do it. The nebula takes up the entire image almost. 2 minutes 10 seconds of worth of frames. That's only 13 frames. The nebulosity around here is now coming out. That's these stars here. You can see that extends all the way up over to here, and you can see here as well. It's extending up past these 2 stars. Like 4 stars up here somewhere. No, it is very good. 2 minutes 40 seconds now of the Lagoon Nebula. I remember looking at this nebula. I was in Spain once. I took a telescope with me, and it was a very impressive misty patch. I think it was a 4-inch. Was it a 4-inch Newtonian or an 80mm refractor? I can't remember which I took, but obviously it was higher in the sky than it is here down in the south of Spain. So it was actually quite an impressive view. In fact, all the views were impressive when I was doing visual astronomy, except when you compare them with just putting a camera where your eye went, and then it's a slightly different matter. I don't feel right now that I have the drive to walk outside and put an eyepiece where my camera is, so I can see some more misty, fluffy patches of indistinct light, while alternatively I can just sit in here and watch it. Now the reason I was looking a little bit perturbed there is there's a 4805 asteroid creeping in down here. I'm wondering if we're inside the... Can't quite make out. There's not two stars here, so that field of view's wrong. We are reversed, aren't we? Do you know I'm going to save a 16-bit fits. Bring it out. Oh. I've never seen that before. It didn't save the... Did it go into dithering? Or was that just me? There we go. Text document, but no. Oh. That works. But if I press save and then go to the folder, I'm just getting text documents and no fits files. Huh. Have we found a bugette? The reason I was is because there's an asteroid definitely in this corner of the shot somewhere, and I thought it might be interesting to see if we could find it, but not that interesting, I don't think. Lagoon Nebula. Let's zoom in a bit. We're at 31 frames, 5 minutes and 10 seconds stacked. And this is the Lagoon Nebula. Not sure we really want to go anywhere else right now. So it's just turning on off the satellites. I think that we have done enough tonight. We've seen another comet, we've seen two planetary nebulas, we've seen the Lagoon Nebula, the Trifid Nebula. I think that's good enough. I might have a little bit of a play and collect some data so I can... So I really want to look into this asteroids and comets and getting them into SharpCap automatically rather than having to fill in notepad documents with RA and declination. But I think I'll leave you with the Lagoon Nebula looking splendid at 6 minutes and 10 seconds.